Astronomers just watched something they can't explain. The interstellar comet 3I Atlas, once barely visible, has suddenly expanded nearly tenfold in brightness and size. No collision, no known cause. One night it was stable. The next, it looked like it had exploded into a cloud hundreds of thousands of kilometers wide. Every model says that shouldn't be possible. And yet, the data doesn't lie. Hello there, and welcome to the Sleepy Astronomer, a quiet corner of the cosmos where discovery feels like dreaming, and even the most chaotic events unfold softly. If these calm journeys through science and wonder bring you peace, subscribing to the Sleepy Astronomer helps this constellation of curiosity grow, so more dreamers can drift beneath the same sky of mystery. Tonight, we follow the strange swelling of 3I Atlas, an interstellar visitor that's doing something no comet should ever do. Is it disintegrating, heating from within, or revealing a structure we've never seen before? Some scientists think it could be volatile gases erupting under solar radiation. Others whisper it might be something far rarer, a fragment of matter reacting to the sun in a way we've never observed. Take a slow breath and imagine a traveler from another star, unfolding itself before our eyes. This is the Sleepy Astronomer. It begins with a faint movement, a small dot of light against the endless dark. It is nothing unusual at first, just another data point among millions. But then the movement becomes clear. It is not orbiting the sun the way asteroids or comets do. It is cutting across space at an angle that no object born here could ever take. That is how you first hear about 3I/Atlas, a visitor from the vast and silent space between the stars. You imagine it traveling for millions, maybe billions of years. It passed stars that have long since burned out, through clouds of gas where new suns were born. It has seen light older than your planet, carried dust from ancient collisions, and remained untouched by gravity strong enough to claim it. You picture it alone in the dark, a cold traveler moving through a sea of emptiness, not knowing where it is going, only that it continues. When it finally enters the edge of the solar system, no one notices right away. The sky is full of motion, comets, meteors, and fragments of forgotten rock. But 3I/Atlas is different. Its path is too steep, its speed too fast. It is not bound to the sun's gravity in the same way. It is just passing through, and in doing so, it gives you and every watcher on Earth a moment to look outward and remember how vast the universe really is. Telescopes pick up its faint light. At first, the data is little more than a smudge on a digital image. But that smudge contains a story, the story of another system, another time. You imagine astronomers leaning closer to their screens, comparing the position of this object night after night, realizing that it does not belong here. The realization spreads slowly, like dawn light on distant mountains. Something from interstellar space has entered our neighborhood again, just as Oumuamua once did. You think about that word, interstellar, between the stars. It means a kind of freedom that is hard to imagine. No orbit, no cycle, no return. Just motion through the infinite. You imagine being such a traveler, carried by inertia, untouched by warmth or wind. You would not see the sun as a light in your sky, only as another distant star that grows brighter for a while and then fades behind you again. Scientists give it a name, 3I/Atlas. The 3I marks it as the third known interstellar object, the third messenger from beyond. Atlas comes from the survey telescope that first noticed it, a machine built to watch the sky patiently for changes. The name feels fitting. In old myths, Atlas carried the heavens on his shoulders. Now, his name is given to a small dot of light carrying the memory of other worlds. As you think of it, you start to realize how strange it is that humans can even notice something so small, so far away. A faint light, drifting among billions of other points, yet we find it. We measure its path, its brightness, its color. From that, we guess its shape, its spin, the way sunlight reflects from its surface. It is almost as if our curiosity is a kind of gravity too, pulling distant things into the orbit of our attention. The scientists track its motion carefully. Its speed is astonishing, fast enough to escape not just the sun's pull but the pull of every planet in the solar system. At that speed, it will only be here for a short time. You begin to see it as a brief conversation between two worlds. It approaches quietly, reveals a little of itself, and then moves on, leaving us wondering what kind of place it came from. Its surface, they say, might be covered in dark material, carbon, dust, and frozen gases. In the cold space between stars, such materials preserve themselves for eons. Some of it may even predate our sun. You imagine that surface, cracked, silent, untouched. Each grain of dust might hold the signature of another star's light, another chemical history. In this sense, 3I/Atlas is like a time capsule, carrying a record of ancient chemistry across light years. You think about how it must feel to exist in that kind of isolation. There is no sound in space, no wind to shape it, no atmosphere to warm it. Yet it endures. Its strength lies not in motion or life but in stillness, in the quiet persistence of matter. It drifts, and that drifting is enough. The thought feels strangely peaceful. As it comes closer to the sun, something changes. It begins to brighten. Sunlight warms its surface, and frozen materials begin to vaporize, forming a faint tail. For the first time in countless ages, it reacts to something light, heat, gravity. You can almost imagine it waking up after an endless sleep, releasing a slow sigh of dust and gas into the void. That glow makes it visible even to smaller telescopes. People across the world begin to hear about it. The news describes it as a mysterious interstellar comet. But to you, it feels more personal. It is not just a comet. It is a messenger from beyond, a reminder that the universe is full of motion and connection. You find comfort in knowing that something so far away can still be seen from here. At night, when you look up, you imagine that faint visitor somewhere among the stars. You cannot see it with your eyes, but you can feel its presence. A small moving light among billions. You think of how fragile and improbable it is that you, standing on a small planet, can know about an object that has traveled through countless years of darkness. It makes you feel small, but not in a frightening way. Small in the sense of being part of something vast and intricate. Every orbit, every movement of a comet or planet is part of a pattern, a quiet dance of gravity and time. But 3I/Atlas moves to its own rhythm. It does not circle, it passes through. The story is one of arrival and departure. You realize that, in its own way, it mirrors many things in life. Moments that appear suddenly, shine briefly, and then drift away beyond reach. The astronomers continue to watch, recording its changing light. Each night brings new measurements, new reflections. They are not just studying a rock. They are tracing a journey. Every bit of data is a step back through time, back toward the place where this traveler began. But no one knows exactly where that is. Somewhere, beyond the nearest stars, a parent system has long since forgotten it. As you listen to this thought, you begin to sense the quiet humility that science often brings. The more you discover, the more you realize how much remains hidden. 3I/Atlas reminds you that even with all our instruments, we see only a faint glimmer of what the universe truly holds. And yet, even a faint glimmer is enough. Pulls you toward curiosity, toward awe. You feel that, in the great stillness of space, everything that travels carries a story, and by watching, you become part of it. In the days to come, the story will deepen. The light will shift, and something unexpected will happen. But for now, you simply rest with the thought that a visitor has arrived, carrying silence from beyond the stars, and that silence is about to change. It begins, as so many discoveries do, with a faint flicker of light. Somewhere on a quiet mountain, a telescope captures a small movement, a single point shifting ever so slightly from one image to the next. The scientists who notice it pause, check the coordinates, and blink. They have seen this before, small asteroids, ordinary comets, wandering fragments of rock. But this one seems different. The brightness changes too quickly, the angle is wrong, and its speed is far too high. You imagine yourself there, watching the screens glow in the control room's dim light. Outside, the air is cold, and the dome above you hums softly as it turns toward the sky. The stars are steady, timeless, yet this single point moves against them, slow enough to be missed by the untrained eye, but fast enough to catch the curiosity of anyone looking closely. They take another image and then another. The faint dot has shifted again. A pattern emerges, not random, not erratic, but deliberate, as though the object has a story to tell. Soon, data begins to flow from other observatories. Each telescope, each observer, becomes part of a shared rhythm, watching, recording, wondering. In astronomy, this is how discovery unfolds. Not in a flash of revelation, but in patience. You learn to trust faint signals, to listen to whispers in the noise. The scientists compare notes, cross-check their readings, and measure how fast the light changes. That is how they know something extraordinary has entered the solar system, a visitor that moves not like the others. You picture the world in motion beneath it. Cities glowing, people asleep, the oceans reflecting starlight. No one can see 3I/Atlas with the naked eye, and yet it moves across the sky above them all, silent and unstoppable. Somewhere, a scientist in Hawaii measures its path. Another, halfway across the world, confirms the reading. Slowly, a collective realization spreads through the global community of skywatchers. This is something new. The data deepens. Its brightness doesn't remain constant. On one night, it grows faint. On another, it becomes suddenly brighter, as if breathing. A comet often behaves this way when sunlight warms its surface, releasing plumes of gas and dust that reflect light. But the pattern here is strange. Too uneven, too alive. You imagine the object turning slowly in space, revealing new surfaces to the sunlight, like a rotating sculpture of rock and ice. Its brightness, then, is not only a sign of melting or gas but of movement, a slow cosmic spin. Each flicker is a glimpse of a different face of the same traveler. Astronomers call this a light curve, a record of brightness over time. It is a simple idea, but it carries deep meaning. Every rise and fall in the curve is a message about what's happening far away. From such curves, scientists can tell how fast an object spins, how rough its surface is, even how it might be shaped. To you, it feels like reading the pulse of something alive. You close your eyes and imagine that pulse. A faint rhythm against the silence of space. Brightness, dimness, brightness again. Like breathing. Like the universe itself inhaling and exhaling through this fragment of ancient material. More telescopes join in, from Chile, Spain, Arizona, and South Africa. Together, they watch the traveler move closer to the inner solar system. With each passing night, its light grows a little stronger. The data shows that it reflects more sunlight than before. Something is changing on its surface, maybe new jets of vapor, or fresh dust released by warmth. Still, the numbers don't quite make sense. The amount of reflected light suggests something large, much larger than what they calculated from its path. If it were that big, it should have been visible much earlier. The contradiction puzzles them, and yet the excitement only grows. For a moment, you imagine the first scientist who saw it stepping outside the observatory before dawn. The air is still. The mountains are quiet. Above, the stars stretch out forever. Somewhere up there, beyond even Jupiter's orbit, the visitor drifts, silent and small. And though the scientists cannot see it with their eyes, they know it is there, because the data doesn't lie. The public begins to hear about it too. Articles appear online, with headlines that sound almost like poetry. A new object from the stars, a visitor beyond imagination. Something is moving toward the sun. People begin to ask questions. Where did it come from? What does it mean? Could it hold secrets of other worlds? But the scientists are careful. They speak with quiet precision. They say only what they can prove, that 3I/Atlas is interstellar, that it moves at nearly 60 kilometers per second, and that its orbit shows it will not stay long. Even in calm voices, though, there is wonder. Each answer seems to carry another question. You sense the excitement and the restraint. The universe has sent another messenger, and everyone knows how brief the encounter will be. In months, it will fade again into the outer dark. But now, while it glows, every telescope points its way. You think about what it means to see. We imagine that sight is simple, that to observe is to know. But the truth is gentler. Seeing, especially in astronomy, is an act of faith. You look at light that has traveled for years, for centuries, to reach you. You interpret, you compare, you trust. You learn that knowledge is built from patience, not certainty. 3I/Atlas teaches you this without words. This changing light reminds you that even data has rhythm, that science, too, can feel alive. You begin to feel that connection, a quiet thread linking your thoughts to distant instruments, to mirrors and sensors and human hands adjusting dials in the dark. Somewhere, in the middle of one of those long nights, a new image arrives. The object is brighter again, far brighter than expected. The numbers blink on the screen, confusing the observers. They recheck the instruments, suspecting error. But the readings are correct. 3I/Atlas has increased in brightness by almost double. The scientists don't yet know what it means. But as they stare at the data, they feel the same mix of wonder and unease that always comes before discovery. Something is happening out there, something no model predicted. And as you drift between curiosity and calm, one thought lingers quietly at the edge of your mind. Perhaps this is only the beginning. When light meets an object in space, it does not simply stop, it changes. Scatters, bends, and bounces back toward those who are watching. That is how you first begin to understand the story of 3I/Atlas. It does not speak in sound or motion, but in light, faint signals that travel across millions of kilometers to reach the mirrors of telescopes and the sensors of satellites. Every shimmer, every change in brightness, becomes a clue. In astronomy, this is how everything is known, by light. No one has touched a comet from another star. No one has stood upon its surface. And yet, by studying reflection, you can begin to see it as clearly as if you were there. The light from 3I/Atlas is pale, but not colorless. It carries with it a spectrum, a soft rainbow of information. By spreading this light into its components, scientists can tell what elements lie on or beneath the surface. The pattern of brightness and shadow, of peaks and dips in the spectrum, tells them where dust dominates, where ice hides, and where organic compounds cling to rock. You imagine this process, the faint signal captured, digitized, and transformed into color lines on a screen. Each one, a memory of how sunlight touched something ancient and far away. Reflection becomes language, and through it 3I/Atlas begins to tell its story. At first, its brightness seems ordinary for a comet. But then, small irregularities begin to appear. Some nights, it reflects more light than the surface area should allow. Others, it dims unexpectedly, as if parts of it vanish into shadow. This is when scientists realize they are not simply seeing sunlight bounce off ice. They are witnessing interaction. Sunlight warming frozen material, vapor lifting dust into space, and tiny particles reflecting light back in unpredictable ways. The process has a name: sublimation. It means the direct change from solid to gas, skipping the liquid stage. When sunlight strikes frozen carbon dioxide or water ice, it doesn't melt. It evaporates instantly into space. The gas escapes with a gentle force, carrying dust grains along with it. These grains scatter light in all directions, creating the visible glow known as a coma. To your eyes, if you could see it up close, it would look like a mist of glitter surrounding a dark, icy heart. But with 3I/Atlas, something is different. The coma grows faster than expected. The amount of reflected light suggests an expansion that doesn't fit the models. Some scientists propose that it has fractured, that internal stresses caused by heating split it apart, exposing new surfaces to the sun. Others suggest that it might have been porous, allowing sunlight to reach deeper layers that suddenly began to sublimate together. You think of a piece of ancient glass warming in sunlight, tiny cracks running through it, releasing trapped air and dust from another age. The idea feels simple, almost tender, a slow unfolding rather than an explosion. Reflection, in this sense, becomes both literal and symbolic. Light shows you not only what the object is made of but what it is doing. You begin to see light as touch, invisible fingers tracing the contours of something frozen and silent, bringing it briefly to life. To measure reflection, astronomers use something called albedo, the fraction of sunlight that an object reflects. A perfect mirror would have an albedo of 1, while the darkest soot would have nearly 0. Most comets have low albedo. They are coated in dark carbon-rich material that absorbs sunlight like velvet. 3I/Atlas, however, shows regions of higher reflection, suggesting patches of fresh ice exposed to the sun. You imagine those bright spots, gleaming like small mirrors in the dark. Each one may have been hidden for millions of years, now revealed only because of this brief encounter with our star. There is beauty in that, in the way sunlight reveals what time had hidden. You realize that when astronomers talk about brightness, they are not just describing light but time itself. Each photon that leaves 3I/Atlas carries a history. It might have bounced from a surface that hasn't seen sunlight since before the Earth existed. It travels through emptiness, across unimaginable distances, and finally lands in a telescope mirror. In that moment, the ancient past becomes the present again. You think about your own reflection, how mirrors show not just the surface but the light that has touched you. The science of reflection, in its quiet way, becomes a metaphor for connection, the way observation is never separate from what is being observed. When you look, you participate. When you see, you change your understanding, and in a small way you change the meaning of what is seen. Scientists refine their models. They simulate how sunlight spreads across rotating surfaces, how the gas jets might tilt the object's spin, and how dust could enhance or soften its glow. The more they study, the more alive it seems. A world of frozen stone and gas, yet behaving almost like a living thing, expanding, breathing, changing. And yet, the light still refuses to tell a complete story. Some readings suggest the brightness has increased by more than any model predicts. The coma is larger than it should be for an object this small. If it has truly grown, the expansion must be extraordinary. You sit quietly with that thought, that something so far away could alter itself so drastically. It reminds you that the universe is not static. Even the smallest things can surprise, defying every rule we think we understand. Outside, the night feels different now. The stars seem sharper, the sky deeper. You know that somewhere out there, that faint traveler continues to move, reflecting light that tells only part of its secret. Each reflection is a question, and each question leads to another. The scientists prepare for more observations. They adjust their instruments, refine their predictions, and wait for the next wave of data. The object is still brightening. The light curve steepens, bending upward in a way no one expected. Something is happening, something no one has seen before. You feel the suspense building gently, like a held breath. The universe is quiet, but not still. In the reflection of 3I/Atlas, you glimpse the moment before revelation, a shimmering pause between knowing and wonder. And as the next image is captured, the data begins to tell a story that will change everything they thought they knew about this visitor from the dark. It begins quietly, almost imperceptibly, in the measurements. A faint increase in brightness, recorded night after night, too subtle at first to notice. But soon, the light grows unmistakably stronger. The coma surrounding 3I/Atlas seems to spread outward, like mist rolling over a hill, soft and expansive. Astronomers double-check their instruments. There is no nearby star, no solar flare, no sudden gravitational pull to explain it. Yet the numbers are consistent, it is expanding. You imagine the object in space, isolated and cold, suddenly becoming larger, as if it were breathing. Its faint outline, once a delicate point of light, begins to fill more of the telescope's field. The change is not violent. There is no explosion, no collision. It is subtle, almost tender. But the growth is undeniable. Something about its surface or internal structure has shifted, and the results are visible even from millions of kilometers away. Theories multiply in the control rooms. Could it be releasing gas from deep inside? Could it be fragmenting pieces slowly spreading outward? Each idea is tested against the light curves, against models of cometary behavior, against the laws of physics. Every calculation seems to fall short. The expansion is faster than sublimation alone could explain, larger than rotation or jet activity would suggest. In every scenario, the visitor defies expectation. You think about the emptiness surrounding it. Space itself is cold and silent. Yet here, A small fragment of another world is changing in ways that are almost impossible to track. You imagine being inside that object, feeling nothing yet moving, seeing the sun's faint warmth reach frozen surfaces that have never felt heat before. Maybe something deep inside responds to sunlight in ways science cannot yet describe. A slow internal release, a rearrangement of dust and ice that manifests as growth. Observers around the world begin to compare notes, images, and spectral readings. Each team sees the same thing. The expansion is not an optical illusion, not a miscalibration. It is real. You picture the scientists, leaning over screens late at night, speaking in hushed tones, aware that they are witnessing something unprecedented. The quiet fascination in the room is palpable, the tension almost tangible. And yet, despite all the instruments and calculations, no one can say why it happens. No known comet in our solar system has grown in this way, not suddenly, not without interaction. It challenges assumptions. It makes you reflect on the nature of observation itself, how even the most precise tools cannot always capture the full complexity of the universe. You imagine the object as a living sculpture of ice and dust, slowly unfolding in the vacuum, its shape softening and stretching outward. Each speck of dust released into the coma catches sunlight, scattering faint glimmers in all directions. It is almost poetic, like frost forming on a window in winter, delicate and intricate, yet impossible to fully contain or predict. The light curves confirm the growth. Every night, the brightness rises more than models anticipate. The coma's diameter appears to double, then extend further in directions that suggest an uneven, irregular surface. It is as if the object is learning to display itself, revealing surfaces previously hidden from view. You think about the history of comets in the solar system. Many have broken apart when near the sun, some exploded, others simply faded. None, however, have expanded on their own, quietly, methodically, without violent disruption. And yet, this one does, moving through the cold void as if it has its own agenda or at least its own mysterious process. The growth raises questions not just about physics but about the limits of understanding. How do we explain a change without cause? How do we measure something that seems to defy expectation? For a moment, it feels as if the universe has stretched the rules themselves, allowing a small interstellar visitor to remind us that not everything can be neatly categorized. You imagine standing beneath the night sky, aware that a small dot of light is doing something extraordinary beyond the reach of your eyes. The expansion is invisible to most, but known through careful observation. It is both a miracle of measurement and a mystery of the cosmos. You feel a sense of quiet awe, of humility in the face of an event that is both gentle and extraordinary. Each observation feeds more curiosity. Scientists plan new campaigns, adjusting instruments to track the increasing size. They measure the shape of the coma, the intensity of the reflected light, and the velocity of particles drifting away. Every new data point confirms what was once doubted. 3I/Atlas is changing, growing, becoming larger than it should be, in ways no one understands. And yet, there is no panic, no alarm, only wonder. The universe has presented something unknown, and human curiosity responds not with fear but with fascination. You feel that same wonder yourself, imagining the tiny traveler out there, expanding silently, a reminder that the cosmos is full of surprises. As night deepens and observations continue, a quiet realization settles in. The expansion may hold secrets about the object's interior, its composition, and perhaps even the history of the system it came from. But for now, those answers remain out of reach. You rest with the knowledge that the universe has allowed a rare glimpse of something extraordinary, and that even in calm, measured observation, mystery persists. And as you watch the faint glow grow in imagination, you sense that the story of 3I/Atlas has only just begun. A story that will continue to unfold in the light it reflects and the questions it leaves behind. You begin by thinking about what comets normally do. They travel through the solar system, dark, cold, and silent, until sunlight reaches their surfaces. When that light arrives, frozen gases warm just enough to escape, carrying dust along with them. This process is called outgassing, and it creates the familiar tails you have seen in pictures. For most comets, this is a gentle, predictable process, a quiet response to heat. With 3I/Atlas, however, the process seems amplified. The increase in brightness and apparent size cannot be explained by ordinary outgassing alone. You imagine the frozen surface awakening like a long-dormant glacier. Ice vaporizes, releasing clouds of dust that catch sunlight, forming a diffuse, glowing halo. But the scale is different, far beyond what the models predict. The comet does not merely react. It transforms. Sublimation, another key process, describes how solids turn directly into gas. For comets, this is what drives activity near the sun. Water, ice, carbon dioxide, and other volatile compounds escape into space, sometimes explosively, sometimes slowly. You picture tiny eruptions across the surface, miniature geysers in the vacuum, each sending grains of ice into a growing cloud. Each tiny particle contributes to the increasing reflection, the visible growth that puzzles scientists. Another theory suggests the structure itself is porous. Perhaps 3I/Atlas is not a solid chunk of rock and ice but a loosely bound collection of material, a kind of cosmic sponge. In this case, sunlight penetrates deeper than expected, warming interior regions that then release gas in bursts. These bursts could be asynchronous, unpredictable, creating patches of brightness and shadow as different areas respond at different times. You imagine it rotating slowly, revealing new surfaces, each one contributing to the swelling appearance. Tidal stretching is a less obvious idea, but it comes to mind as you picture the comet moving through varying gravitational fields. Though it is not close to a planet, the sun's gravity may create slight stresses in its fragile structure. You imagine the subtle stretching of material, barely perceptible, enough to crack layers and expose fresh ice. In this way, even the emptiness of space itself might contribute to the growth. You also think about dust and ice grains escaping into space. A small increase in particles can dramatically affect how much light is reflected. Each ejected grain acts like a tiny mirror, scattering sunlight in multiple directions. When multiplied across millions of grains, the effect is an expanding glow that appears larger and brighter than the nucleus itself. In this, you see a quiet poetry. Matter dispersed yet forming a unified, luminous presence. Chemical changes may play a role too. Cosmic rays and solar radiation can alter the surface over time, breaking down molecules, creating new compounds, and changing reflectivity. These subtle transformations can make previously dark areas brighter, adding to the apparent size as more light is bounced outward. Even chemical reactions in the vacuum, slow and imperceptible, can shape what you see through the telescope. You begin to realize that no single explanation fully accounts for the observations. Perhaps it is a combination. Sublimation, outgassing, porosity, tidal stress, and chemical transformation all working together. Each contributes a small part to the visible effect, creating an overall expansion that defies simple modeling. You sense that the complexity of the universe is mirrored in this tiny traveler, small in scale but vast in implication. As you reflect, you imagine standing on a hypothetical surface of the comet. The sun's light touches ice that has never seen warmth. Tiny jets of gas release clouds of dust into the surrounding space. The surface cracks and shifts, revealing hidden layers. You can almost feel the cold, the silence, and the subtle energy of motion without sound. The transformation is slow, gentle, almost imperceptible, yet powerful enough to alter what you see from millions of kilometers away. The scientists continue to track every change. Each measurement brings new questions. How porous is the object? How fast is gas escaping? Are there areas that remain dormant while others erupt? Each observation adds to a growing puzzle. The expansion is real, measurable, and persistent, yet its exact cause remains elusive. You notice that the growth is not destructive. Unlike a comet fragmenting violently, 3I/Atlas maintains integrity while expanding. It is as if transformation can be gentle, a quiet rearrangement rather than an eruption. The object teaches you that change need not be catastrophic, that in the universe, growth and expansion can be subtle, poetic, and continuous. You imagine watching this process over time, night after night, as data accumulates and patterns emerge. Light curves become charts of behavior, showing rises and falls in brightness, subtle shifts in reflection, and evidence of activity that spans the entire surface. The story unfolds slowly, deliberately, with each new piece of information adding texture to the picture of a distant world. There is also something profoundly humbling in witnessing this. A small object, barely perceptible to the eye, carries within it the evidence of complex processes and interstellar history. It has traveled across the void for millions of years, and yet in a few nights of observation, it challenges all assumptions, reshaping understanding without force, without fanfare. You begin to feel a quiet connection. Through light, through reflection, through patient observation, you participate in the journey of this visitor. Each photon that reaches Earth is a bridge between worlds, a whisper of processes that occurred far from human observation. You sense the intimacy of scientific curiosity, how careful measurement becomes a way to touch something otherwise unreachable. And as the comet continues to brighten and expand, the questions multiply. Could it be larger than anyone imagined? Could its interior contain more secrets than the surface shows? Each answer is partial, and each discovery only deepens the mystery. You understand that the universe does not always reveal itself fully, but offers glimpses, small and fleeting, enough to awaken wonder. You rest in that thought, that transformation can be quiet, subtle, and extraordinary all at once. 3I/Atlas grows, changes, and evolves before human eyes, yet retains its silence, its mystery, its otherworldly presence. And as you watch, you sense that even reflection, measurement, and theory are only the beginning. There is something still hidden, waiting to be revealed, beyond the reach of current understanding, hinting at secrets yet to unfold. You begin by looking at graphs, light curves, they call them. A light curve is a record of brightness over time, a simple line tracing the behavior of an object as it rotates, reflects, and interacts with sunlight. To a casual observer, it may appear as a jagged or undulating line, nothing more than a pattern of numbers. But to those who know, it is a story, subtle, intricate, and unfolding across space. For 3I/Atlas, the light curve reveals more than a simple spin. Its brightness changes are irregular, sometimes gently sloping upward, sometimes dropping in brief intervals, as though the surface itself chooses what to show. You imagine watching the comet rotate, its very terrain catching sunlight at different angles, revealing ridges, depressions, and active regions that release dust. Each variation in the curve corresponds to a secret of its structure, a hidden feature now expressed through reflected photons. The rise in brightness might indicate a patch of fresh ice exposed by a crack or a minor outburst. A sudden dip could mean a shadowed region passing out of view or a temporary slowdown in activity. You think of the curve as a heartbeat, a pulse that communicates the rhythm of a world far away. It is silent, yet unmistakable, like an unspoken language written in light. Astronomers analyze the curves carefully. They use models to infer rotation speed, surface irregularities, and even the angle of spin. For ordinary comets, these patterns are often predictable, following rhythms established by repeated orbits. But 3I/Atlas is different, interstellar, untouched by familiar solar system cycles. Its light curve is irregular, a reflection of its long solitude and the unknown conditions of its home system. You imagine standing on a hypothetical ridge on its surface. The sun strikes your frozen surroundings unevenly, warming ice in one crevice while leaving another in shadow. Jets of gas erupt unpredictably, dust drifts slowly, and the reflected light changes as a result. This is what telescopes on Earth are measuring thousands of kilometers away. In a sense, each instrument acts as a distant eye, recording the subtle communication of a visitor from another star. There is a patience required to read this language. No single observation tells the whole story. Night after night, astronomers gather data, looking for patterns in the noise. Small variations accumulate into an understanding: the rotation period, the size and shape of reflective patches, the timing of outgassing events. You sense the rhythm in this process, the quiet unfolding of knowledge through persistence rather than immediacy. Sometimes, the curve suggests a sudden increase in activity, which may indicate the release of a previously trapped pocket of gas. Other times, small dips hint at uneven surfaces or temporary shadows. You think of it as breathing, not life, not sentience, but the subtle response of a complex structure to sunlight, gravity, and internal energy. The comet communicates without voice, and yet you can feel its presence through careful attention. The irregularity of the curve reminds you that no two worlds behave the same. Even with similar materials, rotation rates, and exposures, 3I/Atlas moves differently, reflecting the unique history of its system of origin. Each spike and dip is a trace of processes that occurred far from the Sun, before the comet even approached our solar system. In a way, the light curve is a memory, recorded in photons traveling across space and time. You notice that the curves are not only scientific tools but poetic in their own right. The gentle ups and downs, the sudden jumps and gradual falls, create a pattern that feels alive. You imagine plotting each data point by hand, connecting them slowly, tracing the comet's subtle dance. The process becomes meditative, a rhythm that mirrors your own breathing as you imagine the distant traveler. Scientists also use color information from the light to enhance understanding. Different wavelengths reveal different materials. Ice reflects bluish light more strongly, carbon compounds appear darker, and mineral dust scatters reds and yellows. By separating light into its components, they can create a map of activity across the surface. You imagine these maps as landscapes, rolling and shifting, each reflecting the complex history of an object far older than Earth itself. There is also motion to consider. As 3I/Atlas moves through space, perspective changes subtly. Combined with rotation, this produces variations in brightness that must be carefully interpreted. You imagine the comet spinning, tilted slightly, revealing one face and then another, casting shadows that drift slowly across the surface. Each rotation creates a new pattern in the light curve, a signature of its unique orientation and structure. You reflect on how much information can be obtained from a simple signal, a few photons arriving at an Earth-based sensor after a journey across millions of kilometers. That signal carries the story of ice, dust, motion, and transformation. And through patient observation, the scientists decode it, translating distant processes into knowledge, into understanding. Even as patterns emerge, questions remain. Some spikes in brightness are unexplained. Some dips do not align with any predicted feature. These anomalies are what make 3I/Atlas extraordinary. They hint at hidden processes, at internal structures and materials that no model yet accounts for. You feel a quiet excitement in this uncertainty, a recognition that the universe is more intricate than any assumption can capture. And as you follow the curves night after night, tracing light with thought and imagination, you sense that this is more than measurement. It is communication across space and time, a quiet interaction between observer and observed. The comet's pulse is subtle, persistent, and insistent, revealing its nature while remaining elusive. You rest with the thought that even in silence, even across incomprehensible distances, the universe has ways of speaking. Light carries memory, and memory carries presence. 3I/Atlas has become not just an object to study, but a teacher, revealing the rhythms of existence through the gentle language of light. And as the next data arrives, showing the light curve bending in ways never before seen, you sense that understanding is still incomplete, that there are more secrets waiting to unfold in its quiet, expanding glow. You close your eyes and imagine yourself descending toward the surface of 3I/Atlas. It turns slowly against a backdrop of infinite black. As you draw closer, the bright coma thins, revealing an uneven body of muted grays and faint blues. The sunlight touches it like a whisper. Nothing here moves quickly. The surface is a slow archive of the universe's earliest stories. Dust, ice, and time layered together. Each particle has traveled farther than memory. Some grains were born in the disk around another star, where gas condensed and dust clumped, orbiting in warmth before being ejected into interstellar space. Others are fragments from collisions, remnants of broken worlds or shattered moons. Over billions of years, these fragments drifted, cooled, and found each other again, forming this small, fragile traveler. You imagine kneeling on that surface. Beneath your gloved hand lies frozen water mixed with complex carbon compounds, silicates, and metal dust. The composition tells a story written in chemistry. Hydrogen and oxygen locked together, carbon chains formed in the distant past, perhaps before the sun itself was born. This is the matter that once built stars and planets, now preserved like an ancient note folded into the fabric of space. Here, time has a different texture. The surface changes with sunlight, but only slightly. As warmth touches the ice, gas escapes, carrying grains of dust away in slow motion. From a distance, this looks like expansion, the comet growing brighter, larger, more diffuse. But up close, it feels like dissolution. To grow, it must release. To expand, it must let go. Each escaping particle reflects sunlight for a few hours or days before vanishing into the void. Yet every one of them carries history, traces of minerals formed near stars, atoms once part of a living cycle of creation and decay. The dust is not just matter. It is memory set adrift. You realize that this shedding is not loss. It is continuation. The comet spreads what it has kept for eons, returning fragments of its past to the cosmic sea. Scientists study these particles when they reach Earth's telescopes. They analyze reflected light to infer composition. Silicate, carbon, ammonia, frozen methane. These are familiar ingredients of planets, of atmospheres, of life itself. The data suggests that even across the galaxy, matter follows the same songs, the same basic chemistry, repeated in infinite variations. You find comfort in that repetition. It means you are not separate from the comet, but part of a larger pattern of dust remembering its origin. Sometimes the escaping material clumps together, forming temporary trails that spiral along its path. The sun's light scatters through them, creating a glowing veil. You imagine these trails as messages, thin handwriting across the dark. They carry not words, but composition, structure, and origin, readable to those who know how to listen. The scientists who interpret these signs are patient readers of ancient languages. Each wavelength of light tells a part of the story. A small dip in infrared means frozen water. A rise in ultraviolet signals carbon compounds. The comet's surface becomes a library of signals, its dust the alphabet. You realize that understanding the cosmos is an act of deep listening, of translating silence into meaning. As the comet continues to expand, something curious happens. The more it sheds, the brighter it appears. It glows not because it gains material, but because it reveals what it has always contained. You think about this paradox, how release can create radiance, how letting go can make something shine. It feels like a lesson written not in philosophy, but in the quiet behavior of ice and dust. Every now and then, a burst occurs, a sudden increase in light as a pocket of trapped gas escapes. The dust flies outward in plumes, and for a brief moment, the comet seems alive with motion. If you could listen, you would hear nothing, but you would feel the shift. A silent exhalation of ancient air, frozen since before Earth's birth. You imagine the scent of that air, metallic and sharp, carrying the memory of starlight long gone. The windless landscape beneath your feet trembles slightly with each release. Tiny grains drift upward, sparkling as they meet sunlight. You watch one rise, spinning slowly, until it disappears. In that instant, you sense how the smallest movement can carry the weight of eternity. Each grain lost to space becomes part of a wider dust cloud that will someday mingle with others. Perhaps one day falling onto another planet, another world, another observer's imagination. You realize that comets are not just travelers. They are archivists of existence. Within their frozen cores lie unaltered materials from the beginnings of the galaxy. Studying them is like reading the first words written in the book of time. But unlike ink on a page, their stories are fluid, changing with every pass near a star. As they lose matter, they write new stories in light, in gas, in reflection. You stand quietly in your mind's eye, looking out across this pale horizon. The sun's faint warmth glimmers on ridges of crystalline ice. Shadows stretch long and still. You feel that this world remembers everything, not in consciousness but in structure. Each atom carries its own story, etched in bonds formed billions of years ago. The comet is growing again, but you understand now that its growth is both physical and symbolic. It grows not by accumulation but by exposure, by revealing itself to the light. What looks like expansion is the universe's gentle act of unveiling, allowing what was hidden to be seen for a brief moment before fading again into distance. As the dust drifts away, you think of memory itself, how it expands and thins, yet never disappears. The particles will keep traveling long after 3I/Atlas leaves the solar system, carrying echoes of the time it crossed paths with your world. Somewhere in the darkness, the dust will continue to glow faintly, scattering sunlight for anyone willing to look closely enough. And as you watch it fade, you begin to sense another force at play, invisible, powerful, and constant. The dust does not simply drift. It is guided, sculpted, and carried by something unseen. The light may illuminate, but another energy shapes the path. The sun breathes outward, and space itself responds. You lift your gaze to feel it, the solar wind beginning its silent touch. The sun never truly rests. Even in silence, it exhales. A constant, invisible stream of particles that fills the vastness of space. You cannot see them, but they move with purpose, a river of charged protons and electrons flowing outward in every direction. It is not air, not wind as you know it, yet it breathes life and motion into everything it touches. From the delicate tails of comets to the faint shimmer of planetary auroras, this solar wind is the pulse of the solar system itself. 3I/Atlas drifts through that unseen tide, its surface meeting a force older than time. The comet carries the dust of another world, the frozen memory of alien suns. But here, it begins to feel the warmth and breath of ours. Particles from the sun strike its surface, stirring vapor from the ice buried deep inside. A faint mist rises, forming a thin, ghostly atmosphere around it, what astronomers call a coma. It is fragile, temporary, and yet, in that fragile veil, something new begins to appear: movement, direction, and light. You watch as sunlight and solar wind weave together. The radiation pushes outward, sculpting a tail that stretches for millions of kilometers behind the comet. It glows faintly blue, the color of charged ions dancing through magnetic fields. Another tail, broader and whiter, drifts alongside it, dust and ice caught in sunlight's pressure. The two tails sway like ribbons, tracing the balance between energy and matter, between what moves freely and what resists. The solar wind does not simply pass by. It interacts, it changes, it sculpts. Every atom of gas leaving the comet's body becomes part of a cosmic dance. The sun's magnetic field twists and folds, guiding streams of plasma that bend and shape the tail's path. What looks like stillness from afar is, in truth, a slow-motion storm, a ballet of charged energy unfolding in near-perfect silence. There is no sound in space, yet if there were, it might hum like the faint whisper of wind through reeds. You imagine standing there, close enough to feel what cannot be felt, the breath of the sun moving across invisible space. The particles are few, scattered across immense distances, yet their touch is enough to move mountains of dust. Here, strength is measured not in weight or speed, but in patience. The solar wind works slowly, relentlessly, reshaping everything it meets across time and distance. Scientists on Earth watch this process unfold through instruments sensitive to the subtlest changes. They see the ion tail grow brighter, see the dust expand into diffuse clouds. They measure shifts in wavelength, detect variations in density. But beyond the data, there is something almost poetic about it. The idea that even emptiness has texture, that the void is not void at all. Space breathes. It moves, it flows, it carries energy and memory in every direction. You think of how similar it is to the wind on Earth, unseen, yet shaping oceans, forests, and deserts. Both are messengers of movement. Both carry stories. On our planet, wind sculpts sand into dunes and clouds into storms. Out here, the solar wind sculpts tales from ice and whispers through magnetic fields. The scale is different, but the principle is the same. Energy meeting matter, motion giving shape to stillness. The comet becomes an artist's brush dipped in plasma. Each pass near the sun paints a stroke of glowing vapor across the night. It reveals the invisible, the flow of the sun's own breath stretching outward to the edge of the heliosphere. You realize that the solar system is not a static place of orbiting rocks, but a living system in motion, bound by the gentle, ceaseless exhalation of its star. In that realization, something shifts inside you. You begin to sense the harmony behind chaos. The tale of 3I/Atlas is not random. It is the visible echo of the sun's rhythm. Every flare, every burst of radiation, every change in solar pressure leaves its mark upon the traveler. It is as if the comet is listening, responding, dancing to a song played across light years. You imagine the path ahead, how the solar wind will continue to guide and shape it as it drifts deeper into the inner solar system. Scientists will trace the fluctuations, model the flow, and debate what they see. But you, sitting beneath the same sky, understand something beyond equations. That this dance of particles and dust is also a reflection of connection. Even in the cold emptiness between worlds, forces reach out, touch, and transform. You think of your own breath, the simple act of inhaling and exhaling. It feels almost sacred now, a reminder that you too exist within a field of exchange. Every breath you take once moved through trees, oceans, perhaps even volcanic vents. The air within you has been everywhere. In this way, you are not separate from the solar wind. You are part of the same motion of giving and receiving, of energy flowing through time. 3I/Atlas continues to glow, its tail flickering like a thought on the edge of memory. Some nights, the telescopes catch it shimmering faintly in reflected sunlight. To the eye, it may appear calm, serene. But behind that serenity lies motion, billions of charged particles, each with its own trajectory, guided by forces too vast to comprehend. It is humbling to realize that even the smallest grain of dust in the comet's wake is being moved by the sun's invisible hand. As it travels, the solar wind carries away traces of the comet's essence. Tiny fragments of its body are lost forever, scattered across interplanetary space. Yet in losing, it also gives seeding space with material that may someday drift into other worlds. This is how the universe creates. Through exchange, through touch, through the endless play of energy transforming matter. The more you think about it, the more you understand that nothing in the universe is ever truly still. Every silence is alive with motion. Every emptiness is filled with unseen flow. The solar wind does not just move through space, it defines it. It creates boundaries where none existed, sculpts invisible shapes, carries whispers of the sun to the farthest edge of the system. The same wind that brushes past 3I/Atlas will, billions of kilometers away, shape the magnetic bow of a distant planet. In every place, it leaves its gentle signature. You picture the edge of the heliosphere, the point where the solar wind slows and meets the interstellar medium, the breath of other stars. Their boundaries dissolve. The wind of one system becomes the space of another. It is a meeting of worlds, a mingling of energies that never truly end. Somewhere, beyond that invisible border, 3I/Atlas once began its journey. And now, it returns to listen to another star's breath, our sun's quiet song. You close your eyes and imagine that soundless song. It is not violent or harsh, but steady and soft, a pulse that keeps the cosmos alive. The comet listens, turns slightly, and continues on its path. Around it, the wind glows faintly in ionized blue. It is a sight of serenity, a reminder that even in the harshest vacuum, connection persists. Energy moves, matter responds, and the dance continues. Somewhere on Earth, a child looks up through a telescope for the first time. They see a faint streak of light across the stars and ask what makes it glow. The answer, simple yet infinite, is this: the breath of our star, touching a traveler from another world. And as you think of that breath, of how it shapes the comet's long luminous trail, you begin to wonder, what happens when our curiosity meets such invisible beauty? What forms does understanding take when data begins to feel like awe? The question lingers, quietly, like the solar wind itself, leading you toward the next mystery. Numbers fill the screens. Spectral lines hum across graphs. Columns of figures scroll endlessly, each one tracing the breadth of 3I/Atlas. Its changing brightness, its expanding shell, its strange heartbeat of reflected light. Yet behind the precision of every data point, something begins to stir. It is not confusion nor skepticism, but a kind of awe, the quiet realization that numbers can describe, but never contain, the mystery of what they measure. You imagine yourself among the scientists, gathered in dimly lit observatories and quiet rooms, humming with the sound of cooling fans and whispered theories. Their faces glow in the light of monitors. Eyes flick between wavelengths and calibration tables. Outside, the real comet sweeps through darkness. Ancient, indifferent, endlessly graceful. Inside, equations try to follow it, to capture its logic, but the comet always seems one thought beyond. The first data returns from the deep space sensors. The readings make no immediate sense. Dust emissions exceed expected values by a factor of 2. The reflected solar flux grows when it should fade. Spectrographs show peaks where no known molecules should be. It's as if the object is rewriting the models as it moves. One scientist leans closer to her screen. "Maybe it's outgassing," she whispers. Another shakes his head. "Not at that temperature." They argue softly, like poets debating the meaning of silence. Each theory is a gesture toward understanding, beautiful, incomplete, reaching. And then, amid all the noise of equations, you feel it. That subtle shift when curiosity transcends measurement. You see how science, at its heart, is not the opposite of wonder. It is wonder, disciplined and written in numbers. The graphs and spectra become brushstrokes in an invisible painting, each point a star in a constellation of understanding. You scroll through the data logs yourself. Every column represents time, distance, density, and speed, but also faith. Faith that what we see in numbers truly reflects what exists beyond the telescope's mirror. The instruments are our senses extended, the universe translated into digits and decimals. Yet the translation never feels complete. Something always escapes, like light slipping through the edges of a prism. You remember how, as a child, you once held a prism to sunlight and saw color spill out. That same feeling returns now, though the spectrum is cosmic, stretched across millions of kilometers. Science measures, wonder feels. Together, they form a language vast enough to speak to the stars. As the data deepens, patterns begin to emerge. The comet's expansion follows a curve, not chaotic, but rhythmic. It pulses faintly, almost alive, as if breathing in the solar wind and exhaling dust. The team models it again and again, trying to find a law to fit its behavior. Yet the more they fit, the less it obeys. Its logic is too fluid, too ancient for equations born on one small world. You lean back, watching streams of information become a river of meaning. The comet is no longer just an object. It is an interaction, a conversation between star and stone, between what was and what is. Each spectral spike is a whisper of chemistry from another solar system. Each flare of brightness, a memory escaping from ice billions of years old. The data are not just numbers. They are messages. You feel time blur. The hours of analysis fade into the same stillness that fills the space between worlds. It's then you realize that discovery is not always loud. Sometimes it arrives softly, not as proof, but as presence. The scientists go quiet. The air in the room feels charged, like the moment before a storm. Someone finally says, "It's beautiful," and no one disagrees. Wonder, once dismissed as unscientific, now sits beside them, silent and radiant. The comet has become both experiment and poem. Through your own eyes, you begin to sense that the act of observing itself changes what is seen. Every telescope, every measurement, is also a reflection, not only of the universe but of human longing. To collect light is to listen to creation. To graph it is to translate that listening into meaning. But meaning, like the comet, keeps moving beyond formulas, beyond language. You picture the data flowing across continents. From Hawaii to Chile, from the Canary Islands to the frozen domes of Antarctica, observatories share their findings. A web of knowledge spreads through the planet, invisible yet luminous. Each node glows with the same pulse, the same desire to understand. The world, for a moment, becomes a single instrument, tuned to the song of a wandering visitor. In that collective effort, something profoundly human emerges. Humility. To admit we do not fully understand is not defeat. It is the beginning of wisdom. Every unknown in the data is a doorway. Every anomaly an invitation to see differently. You remember Einstein's words, that the most beautiful thing we can experience is the mysterious. He would have smiled at 3I/Atlas, this silent enigma tracing light across the solar system. The comet is not breaking the laws of physics. It is revealing where our understanding ends. And in that edge lies the essence of science itself. The next set of readings arrives. The comet's expansion rate stabilizes, then oscillates, then doubles again. It's as if the universe is teasing the observers, saying, "Look closer, but never think you've seen it all." Someone jokes nervously, "Maybe it's alive." Another answers softly, "In a way, everything is." You smile. You understand that what moves scientists to study the cosmos is not just curiosity, it's connection. To measure the light of a comet is to share breath with the sun. To record its changing brightness is to participate in its story. We are not outside the universe studying it. We are the universe studying itself. Outside, the night deepens. The comet glides unseen through the vacuum, unbothered by human uncertainty. Dust drifts off its surface, forming patterns that only light and wind understand. The instruments continue recording faithfully, yet even their precision feels like reverence, the reverence of attention. You zoom in on one of the latest spectra. Faint lines of cyanide, water vapor, and carbon monoxide. The chemistry is ancient, unchanged since before Earth formed. You realize that in these molecules lies the memory of countless worlds that never became stars, the ashes of galaxies long gone. The data are fossils of light. And so, between analysis and awe, a strange peace forms. You see that the universe doesn't demand belief, only listening. That science and wonder are not two paths, but one spiral, winding upward through curiosity toward meaning. To calculate is to worship in numbers. To marvel is to understand through silence. Somewhere, a researcher leans back from her keyboard and gazes at the raw data one last time before sleep. She knows she will dream of the comet, not as a subject, but as a companion. Even in dreams, curiosity continues its orbit. You close your own eyes and imagine floating beside 3I/Atlas. Its tail stretches infinitely behind, a shimmering thread woven from sunlight and ionized wind. You reach out a hand knowing you cannot touch it, yet sensing that somehow you already do. Because to observe is to participate. To measure is to become part of the pattern. And to feel awe is to remember that you belong here, among these motions and mysteries. When you open your eyes again, the data on the screen seems different. Not cold, not distant. You see the poetry hidden within each curve and spike. You see humanity's fingerprint in every equation, not as arrogance, but as yearning. In that moment, the barrier between knowing and feeling dissolves. Science has turned into music. Numbers sing. Light becomes language. And somewhere, far beyond even that, 3I/Atlas continues to write, not in ink or code, but in motion itself. You understand now what the data could never quite capture. That wonder is not what comes after knowledge. It is what makes knowledge possible. Across the world, telescopes keep their vigil. From mountaintops to deserts, from frozen domes to orbiting satellites, humanity's gaze stays fixed upon the same drifting light, 3I/Atlas, the stranger that refuses to behave. The data arrives in clean digital streams, yet the story it tells is anything but tidy. Something inside the numbers refuses to settle into pattern. You imagine the scientists, tired, fascinated, surrounded by screens glowing faint blue in the dark. Coffee cups crowd the tables, charts cover the walls, and the air hums with quiet disbelief. They check and check again. Every calibration confirmed. Every variable accounted for. Still, the comet expands. Still, it defies all models. One researcher murmurs, "It shouldn't be possible." Another replies, "And yet it is." Between those two sentences, wonder begins again. The expansion is not constant. It accelerates, pauses, reverses, and resumes, as if guided by something unseen. It's not gas venting. The temperature is too low. It's not sunlight pressure. The motion is too irregular. It's not debris. The fragments move as one. Each explanation unravels the moment it seems complete, like ice melting under thought itself. You watch them argue gently. No one raises a voice. The mystery is too large for pride. They draw new diagrams, run new simulations, each one collapsing under the weight of the unknown. To study a universe like this is to live in perpetual surrender, to accept that answers come only when they wish to. Across a conference room, someone sighs, "Maybe it's hollow." Another suggests, "Or maybe it's filled with trapped gases expanding unevenly." But deep down, they know none of it fits. The expansion isn't mechanical. Feels rhythmic, alive, almost deliberate. One scientist leans closer to a spectral image and whispers, "It's like it's breathing." The room falls silent. The words are poetic, not technical, yet everyone feels their truth. For a moment, the language of science opens a doorway into something larger. Not superstition, but awe dressed in equations. You imagine them stepping out into the night after hours of calculations, the real sky above them vast and cold. They look up at the same darkness they have been studying on screens, and something in them softens. The comet, now faint to the eye, glimmers beyond Mars's orbit. Not a speck of mystery solved, but a reminder of how much mystery remains. Emails flood in from observatories worldwide. Each team sees something slightly different. Some report brightness doubling overnight. Others detect faint jets where none existed before. The data refuses to agree with itself. It's as though the object is changing faster than we can observe. Could it be an illusion? Someone asks. An instrumental artifact? The response is silence. Every machine checks out. Every calibration holds. The sky is consistent. Only the comet is not. Bafflement turns into quiet excitement. They are standing at the edge of the known, and that edge feels sacred. The unknown, after all, is where science is born. You picture a whiteboard covered in sketches, spirals, shells, lattices of dust. Equations sprawl across its surface, erased and rewritten so many times that faint ghosts of old symbols linger underneath. Each attempt is both progress and poetry. The pursuit itself becomes an act of reverence. In another lab, a graduate student stares at the data in disbelief. The numbers oscillate like waves, no noise, just rhythm. She overlays sound onto the curve, and suddenly the data sings. A low, slow pulse, almost musical, like breathing in light. She plays it aloud for her supervisor, who just stands there, listening. The comet's change has become audible, a heartbeat of distance. They don't know what it means, but they feel it. You think about how fragile certainty is, how every discovery begins not with knowing, but with not knowing, with confusion, contradiction, curiosity. The bafflement spreading through observatories is not failure. It's the first movement of a new understanding trying to be born. In a sense, 3i/Atlas is teaching humanity humility. To look up and admit we don't know. The media picks up the story. Headlines appear. Comet defies physics. Scientists baffled by alien visitor. Unexplained expansion in deep space. Each one louder than the next, but none close to truth. The reality is quieter, deeper. Not panic, not fantasy, but wonder rediscovered. The scientists don't shout. They listen. You see them during interviews. Their voices calm and careful. "We're observing something truly unusual," they say. "We're still gathering data." Each sentence holds both honesty and awe. The world watches, waiting for answers that do not yet exist. Behind the scenes, the work continues. New algorithms are written. Old theories are dusted off. Data is compared across wavelengths, visible light, infrared, radio. The more they look, the more the comet slips away from comprehension, like mist through fingers. In private journals, a few admit what others only feel. That perhaps the comet is showing us the limits of our imagination. That maybe growth, even cosmic growth, doesn't follow the rules we expect. You think of Galileo, Newton, Einstein, all standing once where these scientists stand now, staring at something that broke the known frame of reality. Every era of discovery begins with bafflement. Confusion is not a flaw. It's a compass pointing toward revelation. A senior astronomer, gray-haired and gentle, writes in her notes, "Maybe the expansion is not physical but perceptual. The way we see it changing tells us more about us than it." She looks up from her desk and whispers, "Perhaps we're watching our own understanding stretch." That thought lingers. Maybe what expands is awareness itself. The comet, then, becomes a mirror, reflecting not just light, but thought, showing how human curiosity itself grows, brightens, and evolves. You imagine the team still awake at dawn, staring into screens as sunlight spills through observatory windows. The night's mystery doesn't fade with morning. It only softens. Someone yawns and smiles. "We'll figure it out." Someone else answers, "Or maybe we won't." And that's okay. In those quiet, exhausted smiles lies the essence of science. The joy of asking questions that might never find answers. The comet continues its path, expanding still. Satellites record faint ripples in its tail, like echoes of solar wind playing across a drum of frozen dust. The models keep failing. The beauty keeps deepening. You sense it too, that small, serene thrill of unknowing. To live in a universe that resists explanation is to live in one that is alive. And as you breathe, you realize how much you share with those scientists. You too are a watcher of patterns. You too are puzzled by the way things grow and change, in space, in time, in yourself. The bafflement of the scientists mirrors the mysteries within your own mind. The comet becomes a metaphor, an idea expanding beyond its form, defying boundaries, reminding you that not all growth is visible. Some happens in thought, some in wonder, some in silence. Outside, the observatories fall quiet. The instruments continue their patient gaze. The data flows like a slow river into servers that will be studied for years. But for now, no one has an answer, only the shared amazement that there is still so much to learn. And perhaps that is enough. The bafflement of the scientists is not confusion. It is reverence in disguise. It is the universe whispering, "Look deeper." It is a soft reminder that discovery begins not with certainty, but with the courage to wonder. The comet moves on, farther from the sun, deeper into space, still growing, still shimmering, still unknown. And somewhere, a scientist looks up from her notes and quietly asks, "If we can't explain this, what else might we not yet see?" You sit before the telescope as dawn threatens the edge of night, watching the faint smear of light where 3I/Atlas once burned brighter. The hum of the observatory feels sacred now, a place where silence listens back. You adjust the focus with care, fingertips trembling slightly. Out there, across impossible distances, light is still arriving, delayed, filtered, bent by space and time. You're not seeing what is but what was. The realization humbles you. Every image of the universe is a memory. The screen before you fills with scattered points of data, brightness curves, spectra, residual dust traces. They are your only connection to the comet story now. Through them, you reconstruct an event you never truly saw. The photons that enter your eyes have traveled billions of kilometers, each one whispering the faintest clue about what it touched. Yet, between emission and arrival, so much is lost. Observation, you think, is not the act of seeing, it's the art of inferring. A misreading of wavelength, a dust speck on a lens, a drifting calibration. Any of these can reshape truth. A small error becomes an entire mythology. You remember stories of distant planets that turned out to be noise, of cosmic signals that were microwave ovens. The line between discovery and illusion is as thin as the beam of starlight you chase. And yet, you trust it. You must. Because without that trust, The sky remains mute. You peer again, deeper this time, at the faint region where 3I/Atlas once shimmered. Its fragments, invisible now to the naked eye, are still being traced in wavelengths beyond sight, radio, ultraviolet, infrared. The data streams across your monitor like a living heartbeat. Each fluctuation tells a story. Rotation, vaporization, motion, decay. The universe speaks in frequencies, and you are its interpreter. But interpretation requires distance. You cannot touch what you study. You can only watch, always from afar. And distance distorts. Light travels curved paths around gravity wells, stretched by expansion, blurred by dust. What you see is never the whole, only a filtered version of the truth. Perhaps that is why the act of observing feels so fragile. Every measurement carries your own bias, your assumptions, your hope to find meaning. Even as you analyze data, a quiet longing creeps in, the desire for connection. To believe that what you see means something, that the universe reveals itself to those who look long enough. You take a slow breath and remember. The instruments don't lie, but interpretation does. Still, you can't help but feel awe at the balance. Precision and imagination, math and faith. To measure light from a moving rock millions of kilometers away, and yet not truly know it, that paradox defines astronomy itself. You scroll through archived images from months past, before the outburst, before the comet fractured. The early photos feel almost intimate now. Soft arcs of ice, dust trails like the handwriting of gravity. You trace the curve of its orbit with your eyes and imagine how it must have looked up close. The faint glow of sunlight glancing off its surface, particles lifting into space, forming a tail that shimmered for a moment before vanishing. Your mind fills in what no telescope can capture. Perhaps that is the secret truth. That imagination completes the data. Without it, the numbers remain cold. But with it, the universe becomes alive. Every pixel of light becomes a story of creation, destruction, distance, and time. You begin to understand that observation isn't just passive watching. It's participation. You bring yourself into the act of seeing. The cosmos reflects your own consciousness back at you, distorted but familiar. You lean closer to the eyepiece and think about all the others who have done the same. Ancient astronomers tracing stars by hand, dreamers with polished lenses, modern scientists surrounded by arrays and code. All of them looking at the same darkness, trying to make sense of faint, delayed light. Each one trusted the invisible. And in doing so, they built a bridge across time. For a moment, you wonder what 3I/Atlas would look like now, this very second, not as it was minutes or hours ago. Somewhere, deep in the night beyond your reach, its debris still drifts silently, glinting with the faintest reflections. But you cannot see them yet. You can only imagine their movement. Perhaps that's enough. The art of observation, after all, is not about possessing the truth. It's about staying faithful to uncertainty. You observe not to conquer mystery, but to live within it. To let each new glimpse reshape you slightly. As the universe continues to expand and shift, you step away from the telescope. Outside, the horizon glows faintly. The stars begin to fade, but the data remains. Endless streams of information waiting to be translated into meaning. You realize how delicate it all is. The connection between your mind and the cosmos held together by the faintest threads of light. You whisper a quiet promise to the sky, that you'll keep looking, no matter how dim it becomes. Because every act of observation, flawed, partial, uncertain, is still a form of faith. Faith that the invisible is real. Faith that distance can still reveal truth. Faith that to see, even imperfectly, is to belong. The comet may be gone, but its light still arrives. And you, the observer, continue to listen. You sit quietly, gazing at the measurements streaming across your screen. 3I/Atlas has grown beyond expectation, its icy fragments stretching in ways that defy simple explanation. At first, you thought the expansion was a property of the comet itself, a physical stretching of dust and gas in response to sunlight and solar wind. Yet now, you feel it differently. Perhaps what grows is not just matter, but understanding. Perhaps growth is not always visible in the objects we observe, but in the way we perceive, interpret, and imagine. You lean back and let the numbers settle into the background, like a gentle tide. Each data point, each spectral line, each curve in the graph is not merely a record. It is a story, a reflection of something larger than itself. The comet stretches outward, and as it does, so does your awareness. You recognize that observation is also transformation. Your mind expands in tandem with the object, tracing its movement, anticipating its changes, feeling the weight of its ancient journey. Time itself feels fluid here. The comet's light has traveled millions of kilometers, a delay that stretches perception. You realize that expansion in the cosmos is not simply physical. Stars grow, galaxies drift apart, and even thoughts and ideas unfurl in unexpected ways. Growth can be subtle, silent, imperceptible except through careful attention. The universe is not fixed. It is unfolding, always becoming. And you, in this quiet moment, are part of that unfolding. You imagine the comet's birth billions of years ago, formed from dust and ice in a distant system. Every collision it experienced, every burst of radiation it endured, contributed to what you now witness. Expansion is the accumulation of history, both violent and gentle. The comet has carried with it the memory of countless events, now released into the solar system as a slow, deliberate stretching. In watching it, you feel connected to the vast temporal web that binds all matter. As you reflect, the concept of expansion begins to take on metaphorical weight. Perhaps it mirrors the growth of understanding itself. How knowledge unfolds in layers, sometimes linearly, sometimes chaotically, sometimes unexpectedly. Like the comet, your comprehension has limits, shaped by perspective and instrument, yet it continues to expand with patience and attention. Each observation adds a fragment to the whole, yet the whole remains beyond full grasp. You notice the comet's tail shimmering faintly in your mind's eye, streaks of dust and vapor stretching away in delicate arcs. Solar wind pushes against it, sunlight dances on frozen surfaces, gravity sculpts its trajectory. The expansion is neither abrupt nor uniform. It is alive in its subtlety, a testament to the interplay of forces that govern the cosmos. You sense the same principle applies to your own thoughts. Ideas ripple, collide, and stretch outward, shaping your understanding in imperceptible ways. Learning is expansion, slow, sometimes chaotic, yet continuous. The more you consider this, the more the comet becomes symbolic. It is not merely a frozen body in space. It is an illustration of process. Growth does not require comprehension. Expansion does not wait for approval. The universe stretches because it must, and we stretch alongside it because we participate in noticing, interpreting, and feeling. Observing is a form of becoming, a subtle internal growth that mirrors what is happening in the cosmos. Your thoughts drift to galaxies, massive clouds of stars, themselves expanding and drifting apart over unimaginable timescales. Each galaxy is a collection of histories, bound together yet growing outward, dissipating into space. And even here on Earth, ideas, cultures, and understanding spread in similar rhythms. There is a symmetry, you realize, between the microcosm of thought and the macrocosm of matter. Expansion is universal, manifesting in matter, energy, and consciousness alike. You notice a shift in your breathing, slow and deliberate, as you align yourself with this rhythm. Expansion is not a force to resist. It is a process to observe and inhabit. Just as the comet sheds dust and ice into the void, leaving traces of its history, you shed assumptions and old interpretations, allowing new understanding to emerge. You recognize that insight often comes not from grasping firmly, but from letting go, from allowing knowledge and experience to accumulate naturally over time. As the comet continues to drift, you think of light years as markers of patience. Every photon you observe has traversed space for ages before reaching your instruments. In a way, expansion is the manifestation of time itself. Matter, light, and thought are all bound by the slow unfolding of events. The comet's size is not simply a measurement of distance or volume. It is a record of countless interactions, each one contributing to the structure you now witness. The comet seems larger now not only in physical terms but in significance. Its expansion invites reflection on impermanence and continuity. You are aware that even the most solid-seeming objects are temporary, in motion influenced by unseen forces. Stars collapse, planets shift, comets fragment, and yet every transformation is part of a larger pattern. By observing and contemplating, you participate in that pattern. Growth is not always visible in magnitude. Sometimes it is internal, reflective, and contemplative. You think of the human mind in relation to cosmic expansion. Each question you ask, each observation you record, each moment of curiosity stretches your understanding slightly farther than before. Like the comet, you carry history and context, layers of previous learning and experience that inform your current perception. The more carefully you pay attention, the more your internal universe grows. Expansion, therefore, is not only a physical phenomenon but a psychological and philosophical one, blending the external cosmos with internal reflection. You gaze at the faint images on your monitor, the tail stretching into the void. Dust particles, fragments of history, float slowly into the background of space, unseen yet persistent. You feel the significance of small changes over long durations, the power of persistence, the subtle influence of cumulative effect. Expansion is incremental, almost imperceptible, yet over time, it becomes transformative. The comet is a reminder that change, even when gradual, is inevitable. And observation is the tool that allows that change to be witnessed, appreciated, and understood. Your thoughts wander to the broader implications. The universe itself is an unfolding mystery, always becoming more than it was. Growth is natural, inherent, unavoidable. And within that vast context, your curiosity, your reflection, your participation as an observer is part of that expansion. There is harmony between the movement of 3I/Atlas and the expansion of thought, between cosmic dynamics and the patient unfolding of awareness. A quiet sense of wonder settles over you. You recognize that understanding is not a final state. It is a process of ongoing discovery. The comet's expansion mirrors your own intellectual and emotional growth. Subtle, layered, and continuous. Every observation stretches not only the body of knowledge but the boundaries of perception and imagination. By watching, you become part of the universe's unfolding story. You close your eyes briefly and imagine yourself floating alongside the comet, its tail rippling with light, its dust glowing faintly against the dark backdrop of space. You feel connected to both the object and the act of observing it, aware that expansion is not only external but internal. You sense a quiet symmetry between the motion of celestial bodies and the growth of thought, between matter stretching across millions of kilometers and the human mind reaching toward understanding. Perhaps you think the true significance of expansion is this: it reminds us that nothing is fixed. Growth is not simply physical. It is cognitive, emotional, and perceptual. The universe is a living pattern, unfolding in countless dimensions simultaneously, and your awareness participates in that unfolding. The comet is not merely bigger. It has expanded your understanding, nudged your curiosity, deepened your sense of wonder. And as you return to the data, the measurements, the delicate curves on the monitor, you realize that observation itself is an act of co-creation. The comet expands, the universe expands, and you, by witnessing, expand too, gently, quietly, inexorably. Each pulse of light, each trace of dust, each fragment of history becomes part of a shared rhythm, a cosmic cadence in which you are both listener and participant. The comet moves farther from the sun, yet its influence remains. You sense the interplay between visibility and comprehension, between growth observed and growth imagined. Expansion is not simply about size. It is about possibility, transformation, and connection. The act of noticing, of reflecting, of allowing understanding to stretch into uncharted territory, mirrors the motion of celestial bodies. You lean back once more, breathing slowly, aware that the boundaries of comprehension are not limitations but invitations. Each expansion, each shift, each subtle change offers a lesson. To witness, to reflect, to grow alongside the universe. The comet has shown that growth is continuous, subtle, and intertwined with perception itself. And in that realization, you feel yourself stretching, thoughts, awareness, curiosity, all expanding gently, like dust particles catching sunlight in an endless void. Somewhere far away, the comet continues to drift, silent, radiant, and ever-expanding, carrying its ancient memory into the infinite. And you, too, carry the quiet expansion of understanding, feeling the universe unfold both outside and within. The story of growth is not yet complete, and you sense that even as you rest, the unfolding continues in the comet, in the cosmos, and in yourself. The comet drifts beyond the reach of your instruments. 3I/Atlas, once bright in your mind and in every telescope, has become a faint whisper against the vast backdrop of space. You sit in the quiet of the observatory, letting the silence settle around you. No screens flicker, no alerts arrive. The world continues its orbit, the sun rises and sets, and yet a small part of the cosmos has moved beyond immediate understanding. You feel the pull of absence, a gentle emptiness left where fascination once thrived. Even as the comet fades, its light continues to travel, a long-delayed message reaching your instruments only minutes or hours later. You are aware that you are always behind, that observation is a conversation with the past. What you see now is never the present but a shadow, a trace of events that have already unfolded. You realize that all of science is like this, an ongoing dialogue with what has already happened, reconstructed through signals that have crossed unimaginable distances. The telescopes are quiet now, their lenses and sensors resting, but your mind continues to orbit 3I/Atlas. You replay the journey, from first sighting to the baffling expansion, the fragments drifting apart and yet moving as one. You remember the scientist's quiet astonishment, the careful data analysis, the blend of calculation and intuition that allowed understanding to grow even when certainty could not. You recognize the sacred rhythm of discovery, the slow cadence of questions, the gentle persistence of curiosity, the patient unfolding of comprehension. Out there, the comet is beyond immediate reach, yet it has left an impression, a subtle imprint on your imagination. Its expansion, its mystery, its very existence has altered the way you perceive growth, motion, and time. You realize that observing the universe is not only about gathering facts but also about internalizing perspective. Every measurement, every faint signal carries a resonance that reaches beyond data into thought, feeling, and reflection. You close your eyes and imagine the comet, small and bright against infinite darkness, carrying its dust and ice, its ancient memory of distant stars. You see its tail stretching outward, faint streams of vapor illuminated by sunlight, dissipating into the emptiness of space. There is a quiet dignity in its motion, a rhythm that is independent of your understanding yet profoundly affecting it. You feel connected to the universe in a subtle, almost intimate way, aware that your consciousness and curiosity form a tiny part of a larger unfolding. Even as the comet fades from direct observation, the lessons it offers linger. You reflect on the scientists' humility, on their willingness to embrace bafflement, on their acceptance that not all questions have immediate answers. There is an elegance in uncertainty, a serenity in realizing that knowing is not always the goal. Presence, attention, and reflection carry their own quiet significance. To witness, to listen, to engage with the unknown, this is as much a part of understanding as any equation or image. The expansion of 3I/Atlas has become more than a scientific curiosity. It is now a meditation on growth itself, physical, cognitive, emotional, and temporal. You sense that all things, from comets to galaxies to ideas, unfold in layers, stretching and shifting over time. Change is constant, subtle, and often imperceptible. Observation, like patience, allows you to perceive these shifts, to feel the gentle pulse of transformation, and to recognize your own role in the ongoing story of the cosmos. You imagine the comet moving ever farther, its dust dispersing slowly, its tail fading into the darkness, yet leaving traces behind for instruments, future scientists, and the imagination of those who watch. The past is preserved in these traces, and the future is carried in their trajectories. You understand that the universe is both record and projection, memory and potential, a tapestry woven from the motions of matter, light, and time. There is a quiet intimacy in this understanding. You are alone in the observatory, yet not alone in experience. The comet's journey intersects with countless other lives, those of the scientists who traced it, the engineers who built the instruments, the thinkers who contemplated its motion. And in this, you sense a web of connection that stretches outward, invisible yet tangible, linking observer and observed across space and time. Your mind drifts to the concept of silence. The stillness of the comet beyond your reach is mirrored in your own contemplative pause. In letting go of immediacy, in accepting absence, you find a different kind of presence, one that is attentive, reflective, and aware. The universe does not demand answers. It offers insight to those willing to notice. You feel the subtle hum of understanding beneath the layers of mystery, a resonance that lingers even after the phenomenon itself has passed from view. You imagine future nights, when telescopes will search the sky for other travelers, other fragments from distant worlds. Each discovery will bring curiosity, bafflement, and reflection. The story of 3I/Atlas has become a template for wonder, a reminder that cosmic events are invitations to expand perception, that even temporary phenomena leave lasting impressions, and that the act of observing is itself transformative. The comet's fading light carries lessons about scale, distance, and the impermanence of forms. It reminds you that the universe is vast and patient, that processes unfold over timescales beyond immediate comprehension, and that engagement with the cosmos is as much about internal growth as it is about external measurement. You feel your own awareness stretching, subtly, quietly, in resonance with the comet's expansion, even as it moves beyond the reach of instruments. You notice the faint glow of dawn outside the observatory. The world is turning, the sun rises, and the night sky is replaced by soft morning light. Yet within you, the darkness remains luminous, a reflection of the mystery you have witnessed. The questions raised by the comet are unresolved, and that is precisely their gift. You do not need closure to feel the depth of experience. The process of observing, reflecting, and imagining is sufficient. You take a final look at the empty sky, knowing the comet has moved on. Its memory lingers in data, in thought, and in the quiet echo of wonder it leaves behind. You feel a soft expansion within yourself, the gentle broadening of curiosity, patience, and awareness. The universe has whispered a subtle truth, that growth, understanding, and presence are inseparable, and that even in silence, there is movement, rhythm, and life. You breathe deeply, imagining all the unseen things that drift through space, carrying light, matter, and memory. You sense the quiet pulse of the cosmos, a rhythm that continues independent of human comprehension, yet intersects with your consciousness in small, profound ways. In this stillness, there is connection. In absence, there is presence. In mystery, there is understanding, soft and incomplete, yet enough to cradle your attention and imagination. And as you close your eyes, letting the final traces of starlight fade from your awareness, you carry the quiet knowledge that the universe continues its motion, expansive, patient, and luminous, and that your mind, too, has grown in its gentle orbit around what once was, what still is, and what will always remain unseen. The story does not end. It continues in thought, in observation, in the soft echo of light that travels endlessly through the void. And in this quiet, you feel a profound calm, a sense of belonging to a universe that moves, shifts, and expands, silently, gracefully, and eternally.